the heart. I'm going to hand out the information. Did you get the dissection thing? No, yeah. It's just a handout. I said there's a little video. I might talk for a little bit, and we'll go. So you probably had enough of my bad artwork. I certainly have. I sent you the other one, so I'm going to do a little bit of A, and it doesn't take a whole lot long because there's a lot of redundancy in this. So let me get through this. Okay, so from a standpoint of practical perspectives, this diagram gets used a lot. There's a lot on there because you can see this is the anterior view with these cow hearts, which are huge. You only have two of them. So you have two groups. Part here, kind of what it looks like. The anterior aspect would be looking here. So we left ventricle, right? And so the labeling is kind of on the back. Same for that. That helps you with getting the orientation. So effectively, that's this view if we took off the top. Didn't it? So what we have, therefore, it's hard to find the vessels. That's what the probes are for, because you almost have to be able to insert into these openings and determine where they go. Do they go into the right atrium? Do they go into the right ventricle or left ventricle, left atrium, etc.? You're even going to see that, like, the veins completely flatten out. The arteries, because they have elastic tissue in them, tend to maintain your shape a little bit. So the opening is a little bit more clear and distinct. Veins, it's just almost like they're completely kind of wide. That's what veins look like, more than anything else. So you'll see this, and again, you should with any, and I'll show you. You're going to have to do it in such a way. It doesn't really matter because we'll probably beat up those hearts pretty good that are there. So as you can see, the ventricles, most of the volume. The ventricles may appear different. That's because the left, being as thick as it is, the muscularity of it, the muscle's 3 to 4 times thicker. What that means, it appears larger. So again, it's almost folded in on itself. That current thing of folding. I talk about most excessively. So indeed, for the cow heart, it doesn't quite look. This would be more of the human heart. The right ventricle, at least the anterior surface, seems to be predominant. I think in the cow, you see most of the left ventricle. And then the left, in the human, the left ventricle is more along the side and the back. But interestingly, the left coronary artery, which we're going to look at, that plays a pivotal role supplying the left side of the anterior portion. You're going to see when I show you the coronary vessels on the soul side, I'm going to show you it again. You're going to see those vessels. I mean, and on any of these hearts, you really don't see arteries. You'll be able to identify coronary sulcus and the soul side between anterior and posterior. But they'll have this dark material. Those are typically veins. So anatomically, veins are on the exterior, then arteries, and then nerves. They all flow in those areas. So we call it a neurovascular bundle. Veins are always more superficial to the surface. Arteries are below, and veins deeper. We used to use the acronym VANAD for a little bit. Veins, arteries, and nerves from above down. I just got in contact with a guy from my study group who I actually grew up with in the same hometown. Went to medical school with. We'll probably talk. Unlike me, he's retired. It's okay. See, what's wrong with it? Oh, we like to spend a lot of the summer in the Mediterranean. Blah, blah, blah. I'm teaching a bunch of people. So most of the anterior surface and the posterior inferior surface in the human are really what you appear on the surface. Here are the trabecular carneae, however you pronounce it. In the interior of the ventricle, again, it's about surface area. When they're folded, they appear more distinct. When it fills with blood, less so. In our hearts, you think the ventricles are large, they're not. 4 ounces each ventricle, about 120 mils. And what do you see when we get into physiology? You think it all pumps out when our heart only about 70 mils. We call it the ejection fraction. We talk about physiology. Our heart is very efficient, yet it only pumps out 57% approximately of the fluid. And we have to maintain that consistently. And the papillary muscles and the chorda tendineae I had shown you. The ventricles, thicker walls, pumping chambers, pulmonary and aorta. That's the largest artery. Again, the inferior vena cava is the largest by diameter blood vessel. Same illustration. So you see there's a lot here with this illustration. You can have the chorda tendineae, the papillary muscles. These are called pectinate muscles, these little ridges. And again, as it fills, and they're typically located in the auricles that are there, those ear-like sections, you'll see those. And this, I mean, I don't get a lot out of this. Here you can see the myocardium, how thick it is. Here's that little fossa ovalis, the one that, you know, sometimes will be open. Here, those pectinates. Again, it derives somehow, pectinate, I don't know what the derivation is, like little fingers. But again, they're just folds, and then when they fill, they flatten out. It says accordion, please. Here you can see the chorda tendineae. This would be a human heart, obviously. It's there. You can see the vessels, all that. I mean, if these help you, great. I mean, if that helps you, great too. Yeah, again, this is a little bit different. So they've been able to do a pretty good cutaway and start to show you the coronary. Here's that coronary sulcus. This is left. This is right. So the right coronary artery in the sulcus, and here you have the left coronary artery just starting there. This giant branch that goes down is now called the anterior interventricular artery. In the old days, it was called the left anterior descending. The name they gave it was the widowmaker, because men were much more prone, at least at that point in time, to heart disease. And that serviced the left ventricle. If the heart attack came from that being blocked, the prognosis is very poor. Just to show you. And you're going to see some of the other arteries that are there as well. And there's really only 4 branches you will need to know. Both the right and left, you're going to see there, and you're going to see the branches that are associated with them. That's what you're going to need to be familiar with. So, unidirectional blood flow, open and close, pressure changes, atrioventricular, semilunar, doing over. Inertia of blood coming through, and understand you're going to see what causes, when we get, I'm going to sneeze, what causes in physiology, the blood flow. We have a lot of auxiliary pumps, the muscles in our calf, our respiratory muscles, the heart itself. It's sort of like, the way I would describe it, if you're familiar, is a siphon. So if you ever had to siphon something, it's like you take a bulb syringe. I'm thinking Thanksgiving, I'm thinking the turkey. Then I'm always thinking the turkey. 3 people don't like turkey. You know, bulb syringe, turkey baster, what you got? When you squeeze it, it spits it out. When you release it, it sucks it back in. The heart, when it pumps, pushes it out. When that contraction releases, effectively it creates a suction pressure. That's how a siphon works. Your muscles in your chest and respiratory muscles and the process of respiration works like that. You have an identical one in your calves. You even have one that's similar in your ankle. Just to give you an idea of how efficient the body is for bringing that back. That's more physiology. So here you can see where they got their names, bicuspid, tricuspid. I don't get the bishop's hat out of that, but I'll go with it. Okay. And I wouldn't be able, I never get from these dissections what it looks like. So again, tricuspid, 3 cusps lie between right atrium ventricle, mitral or bicuspid, chorda tendineae, papillary muscles. Pretty good view that way. Tendineae. Pretty good schematic for all that with regard to the blood flow. And that whole cup-like activity, I mean, you really kind of need to get a girl. I mean, Dr. Buxton was showing, we actually had a student, his advisee, or he was advising the research for her senior project. And we ordered, or she ordered, so you can get the valves, and she was doing pressure readings and things like that. That was a while ago. I don't think anybody's done that in 10 or 15 years. It's there. So here's that cup-like structure. That's a pretty good illustration. So they call them cusps of the AV valve. Here they're closed, and then obviously they could open. The semilunar valves, really important. When we get to the physiology, again, pushing it out, and when the pressure is gone, and you're going to see that phenomenon when we look at blood vessels called elastic or conductive arteries, which are synonymous in terms of arteries. It's like a rebound that occurs. All of this is the little nuances in the human body that make it so remarkable and so efficient. Elasticity when we need it, flexibility when we need it, rigidity when we need it, etc. All sorts of neat systems. So incompetent valves, backflows to the heart repumps, inefficient. Stenosis, stiff flaps, constrict the opening. And here, because of that, the pumping action is really problematic. So, I mean, anything that causes an imbalance one side or the other, as I've said to you, anything that limits the efficiency of this remarkable organ that beats so constantly is really a problem. And again, when we look, and that's the whole thing, I don't know enough about the modern state of valvular repairs. But again, if you're using, if you're replacing something, now you're having to deal with, and the whole idea of having to use, antithrombotic agents, blood thinners, that's always been a big problem. Because they're not selective, they thin your blood all over. There's a whole new science with that. These blood thinners, and I don't know, I'm not familiar with the pharmacology. For years, those blood thinners, the problem was people will bleed, and now you're having to deal with what happens if they cut themselves? What happens if there's a bleeding problem somewhere else? How are we able to control that stuff? It's very difficult. We do it selectively when we need to, but how do you undo it when they have to be on constant medication? So there's been some changes in that as years have gone on. So this is just a tracing of blood, blah, 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 back, forth, around, and through. Equal volumes of blood are pumped to pulmonary systemic. Pulmonary short and low pressure, lazy river. Systemic, long, high friction, raging rapids. And I said the ventricle 3, maybe even 4 times, pumps with that considerably bigger pressure. Schematically, the openings are the same. Here, because there's less muscle, we see more volume. But if you stretch them out, they would be identical. Again, it's all about right and left side equally, simultaneously, etc. The coronaries. The functional blood supply to the heart itself. Shorter circulation, just like the same. Basically, it's a variation of systemic circulation. Again, you'll see when we look at the percentages of flow, about 5%, 1/20th of your cardiac output. We get into that when we do physiology. Cardiac output is what's called stroke volume, the amount of blood that's ejected into the aorta times the number of beats per minute. And so for most of us, they kind of use the way they do it, the way they're able to do it. We possibly have, maybe we're every minute we have anywhere between 5 and 6 liters of blood. What we call the minute volume or the cardiac output. Minute volume is a respiratory measure. That's why they're tied together for aerobic exercise. What we call, again, CPR. So that's part of it as well. The left and right coronary arteries arise base of the aorta immediately after the aortic semilunar valve. They encircle the heart, and the beauty of this circulation is they have connectors. So if one is damaged or one is partially blocked, or even a small tributary is partially blocked or totally blocked, We have a workaround. We have a functional detour. It's unlike PennDOT. PennDOT is, we swear that they close roads and you cannot get from point A to point B. Here you always can. So and the name of these junction points are called anastomoses, which translates to something I don't need, another mouth. For the sleepy group here in the row closest to me, what I don't need, another mouth. Spaceballs. So both encircle the heart. Anastomoses or traditional roots cannot compensate for a true artery occlusion. I mean, if it's blocked, and that's going to cause damage. So I mean, this is the kind of thing. It's another one of these things where the body has all of these alternative pathways. It sounds great until you get a false sense of security and somebody keels over. It's very troubling. As we go through physiology and anatomy together, you're going to see a whole lot of these come up. It's this wonderful amount of safeguards that we have until it's too late. Look, I'm sitting there with bladder cancer developing, and all of a sudden, until I start to pee bright red, it doesn't occur to me that something terrible is going on from all those cigarettes I was smoking and still smoking. And all of a sudden, oh, got it? Don't be surprised. 1/20th is right. The left interventricular septum, that's the left anterior descending, what we now call the anterior interventricular artery. And because they go around, it's circumflex. The word circumflex and vascular means it goes around to the back. The right, as you will see, right ventricle, it goes along the margins and goes all the way to the back and forms posterior interventricular arteries, you will see. So here's the left, here's the right in that sulcus, that coronary sulcus. Here's the circumflex going around back, and you're going to see anastomoses with this here. That's an example of anastomoses. Here's the right. It's going to form the posterior interventricular artery down here, and it's going to anastomose with the anterior ventricular artery. There's more. There's about 9 named vessels. We're just keeping it to these 4 and knowing that they're branches off the right and left coronary artery. And the veins, called cardiac veins, we don't have to know their names, great, middle, or small, anterior, posterior, whatever. They all empty into this widened, flattened area vein, which is a sinus. When we get to veins, you'll hear about more sinuses. They're different than a sinus, like you have a sinus cold. And they merge together. This is there. And you can see there's also, and if anything, veins have more anastomoses than arteries. Veins all kind of connect with one another. Interesting thing about veins. And here on the posterior, I'll show you the posterior view in a jiff. So I think I skipped through it. Back here. And that's the one that empties in. Here it is. Here's a posterior view. It's a classic view. I never, because it's so buried in fat and muscle, it collapses so much, it's almost impossible to find the inferior vena cava, which is much more posterior. Again, the emptying point here is much more posterior. Remember, I told you there's 4 veins. So typically you have 2 on the right and 2 on the left, and they correspond with the right and left pulmonary arteries that come off of the central line, the pulmonary trunk. Here's the aorta. Superior vena cava typically confined. Here's the sinus itself, and then you can begin to see these. Here's the posterior interventricular artery kind of coming off the right artery and down to the posterior interventricular artery. So you can begin to see these structures kind of up close and personal. And then what happens, chest pain is not, it does not necessarily mean a heart attack. Sir?
How does the buildup of fat on a heart work? Like, is there a way to, like, that we can build up fat on the heart and use fat?
Not really. It's very the fat on the heart is really more protective. We have fat around the kidney. We have fat around other organs. It's mostly protective and insulating. When somebody is overweight, it's not around it. It doesn't necessarily play a role with energy or anything like that. So it's basically stationary is the wrong term, but it doesn't vary a lot with your overall level of fitness. I think that's the best way to say it. Interesting. So a lot of these, it's typically, and it's nothing genetic or anything along those lines. It's a good question. So the thoracic pain, let me say, it's all a matter, it's supply and demand. You can have a heart attack and die because you take your heart is not in good shape and you over test it. So it requires an immense amount of supply, immense amount of demand, and you have a limited supply because the vessels aren't pristine. Every winter, you will read in the newspaper or online, somebody goes out, that first snow is heavy, it's wet, they go out, they haven't shoveled anything, done any physical activity in a year, go back out and start to shovel and they keel over. Here, every time, it's typically older, somebody my age, but I'm going to clear the driveway off. Boom. I'm not making light of it. And that's part of the idea of you have to be so careful for people, for all your older relatives, they realize they need their cardiac shape, cardio is important, and not to overtax themselves. I mean, I go out, I shovel for a little bit, I go back in. It's cold to start. That's not easy on the heart. So that's the first thing. That's where it's not a complete blockage. So angina is the alarm clock. Pain in the chest. It means something. Sometimes it means, yes, it may be damage. And damage, an infarction again, myocardial means the heart. Infarction is death of heart muscle due to lack of blood supply. That's what an infarction is. It has nothing to do with an infection. Death of, when we talk about brain, that's a cerebral infarction or a cerebellar infarction. So prolonged is probably a good word. It doesn't have to be complete. To tell that the cells die and are repaired by scar tissue, it's inefficient. It may or may not limit you. Some people find the diagnosis coincidentally when they're going in for a surgical procedure. Maybe I told you what happened to me. I was going in I was having a prostate procedure. It was enlarged rather than being cancerous. Didn't I tell you that about the EKG with my doctor? This is a few years ago. He's retired. And it's like, I get the report on like my UPMC or my chart. It says, interestingly enough, it goes, there's evidence here of a previous myocardial infarction, blah, 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 blah. And then underneath it, no change from last time. I flipped. I looked at the last report, said nothing about it. I went and talked to him. He goes, what they're doing now is they are AI reading. They are computer read. And there were aspects on that from wherever that tracing was that was transmitted to them that were compatible with that diagnosis. He said, no one read it. In the old days, a cardiologist would read all of those. That's kind of what's happening. And he goes, you never had a heart attack, you had no evidence of it, blah, 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 blah. Scary. I almost had it. We had a little discussion. Hey, WTF are you talking about, Doc? Kind of like that. So that's the difference between angina or anginal pains, and they're very distinctive. The old elephant standing on your chest, referred pain down the left arm, up into the throat, difficulty swallowing, abdominal pain, again and again. If anybody in your family who's older and has those risks on, if they're overweight, middle age, however you want to define it, inactive, terrible diet, get their asses out. You cannot, because you could lose somebody if you're not being careful. People dismiss it. Thanksgiving, Oh, yeah, I ate too much. Oh, my God. Didn't go out and play touch football. All right, all right. Not much more here. So, I mean, this is the muscle cells themselves are different. What's interesting about them is the fact that they are short and branched. There's fat and they're interconnected. One or two nuclei. It's definitely, they're not multinucleated like muscle cells. Big mitochondria. Okay. And then we'll get into these kinds of things, something we do in physiology, T tubules, EDT, so it's a little cart before horse. That's why I'm not spending a lot of time on it. I'm just trying to give you an idea. Okay. And effectively, the big deal, I'll show it to you. This muscle is constantly contracting. Each heart muscle, it's kind of like this. They branch. So it kind of does this. And it's connected to the next one. And then that branches and that's connected to the next one. And this branches and connected to the next one. So they're all interconnected. These intersections are called, as you can see, an intercalated disc. There is a lot, and the reason the signals go from one to the other, it's filled with gap junctions. And on top of that, the fact that it's constantly contracting forever, hopefully, you end up with desmosomes that hold it together, prevent separation. The gap junction is effectively charged particles, making the electrical coupling. The fancy name you can see there is a syncytium. It's a fusion. Okay? They're all fused together in a way. That's desirable in the heart. If you hear about RSV, the three, when they're trying to get you, this is opinion, when they're trying to get you to get vaccinated for everything under the sun, you have three. Oh, we're going to give you all three. Believe me, they want to do one. COVID, flu, RSV. That's the big three for the winter virus. Respiratory syncytial virus. It causes, the virus causes lung cells, lung tissue to fuse. Bad thing. Heart's a good thing. Then we can't get adequate exchange of virus. So they're trying to convince you you don't have this vaccine, you're going to die tomorrow. Like the COVID vaccine. So only 3% of your faculty didn't have it. I'm a proud one to be not one of those 3%. Good Lord. So I know to go to school, people had to have it. They still make you have that stupid shot to get here. Thank God. When we had the lockdown in 2020, for them to come back in 2021, you're forcing students to have that if they want to call it the shot. I had students who had myocarditis. Be informed. So intercellular space between the cells is connective tissue matrix. Endomysium, that's fine. Lots of blood supply. Connects cardiac muscle to skeleton and giving something to pull against. Fine. This is what it looks like. These are the desmosomes. These are the gap junctions. This is what it looks like microscopically. Very distinctive tissue. You can see the striations. That implies strength. This is the schematic surface area. Okay? All about that. You can see that peg and hole kind of apparatus that you can see there. Effectively, that, again, it's surface area. The more surface area, the easier to send the signals. The more gap junctions, the more desmosomes. Form and function. We'll get into what happens in T tubules, sarcoplasmic reticulum, and blah, 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 blah. We'll save the conducting system for next time, bless you, so you can get out of there a little. We'll start with that on Wednesday, so I'll leave it here. I mean, that it's important because it's more physiology, but what I'm going to try to get to is the last bit of anatomy. I'll just show it to you. So it won't take us terribly long. But I do feel this should be part, is the electricals. This is the basis for us doing EKGs down the road. We'll do them with mandatory volunteers here. Be ready to volunteer. It's involving this stuff. Look at that diagram. That's the conducting system. That we will study anatomy. So I'll leave that there. Let me